Okay, previously to this moment, we've seen I and it showed up before, but now we're going to focus on some characteristics of I and really to get to what does I actually mean. So I we refer to as the imaginary unit. Simply means that we at some point in time have got the square root of -1 has shown up. Just a couple of basic I facts. I squared is equal to -1. I itself happens to be the square root of -1. And then when we have I, that means we're dealing with some form of complex number. And a complex number is anything of the form a plus bi, where there's a real component, which is the a, and then there's some I component, which is imaginary. It's kind of like x's and y's. So when we plot points, we have a horizontal and a vertical component. Here we're talking about a real component and imaginary component. Now, for our standpoint, what we're going to do with this is we're just going to look at simplifying a couple of operations within imaginary numbers. So, for example, adding and subtracting imaginary numbers. Starting with this, so that minus sign we can distribute in to the second term. So we end up with 3 plus 5i. A negative and a negative means plus for the 2, and the negative and the plus 3i, a negative times a positive gives us a negative 3i. And then from here, we can combine like terms. So I see that the 3 and the 2 combine to 5. And the 5i and the minus 3i, we can add those together to get positive 2i. So when subtracting these two complex numbers, we end up with 5 plus 2i as the final answer there. Again, similarly, we can subtract these two numbers here. So we can distribute that negative in to the 3 plus 6i. So 6 plus 4i. The negative times the 3 is minus 3, and that's minus 6i. And then I can look for like terms. So 6 minus 3 is 3. And the 4i and the minus 6i gives us negative 2i. So that's our simplified form. All right, we can also multiply complex numbers. Now, from our standpoint, this kind of looks very similar to foiling or double distributing. So I would take the 5 times the 2 and the 5 times the 7, and that would give me 5 times 2 is 10, and 5 times 7i is 35i. And then I would distribute the 3i times 2 and the 3i times 7i, which gives us 6i plus 21i squared. Now, here's where it gets a little interesting for us. I'm still going to combine like terms. So at this point, I don't really have anything that goes with the 10, sort of. It's a little deceptive there. I can do the 35i and the 6i to get 41i. But that 21i squared, we're going to remind ourselves that I squared is really, remember, I squared is really negative 1. So I can replace that I squared with a negative 1. And now I've got something that will physically combine with the 10. So I'll come back over here. I get 10 minus the 21 plus the 41i. And so 10 minus 21 is negative 11. So negative 11 plus 41i. And you'll see that happen anytime we're multiplying two complex numbers, where you'll get the I squared to show up, and then it will combine together with any other whole number or real number expression. Now, underneath the realm of imaginary numbers, we have this idea of a conjugate. So symbolically, this z with a line on top is just algebraically how we indicate, oh, you're dealing with a conjugate. And we can even get more specific and say that if I'm staring at a plus bi, the conjugate is simply a minus bi. So that sign in between the two a's and b's, so the numbers match, but the sign in between them is what actually changes. So in this case, the 3 plus 5i, the conjugate of it, so the 3 and the 5i are going to stay the same, and the sign in between it is going to change. Now, something very interesting happens when you end up multiplying two conjugates together. So I want to kind of show this to you. So we're going to FOIL or double distribute, depending upon how you want to look at it. So we'll multiply those together. So we get 2 times 2, which is 4. Then we get 2 times minus 5i on that side. And then when we distribute the 5i in, I get 5i times 2, which is plus 10i, and minus 25i squared. Now, what happens to the 10i's? Well, the minus 10i and plus 10i, those guys cancel out. So we're left with 4 minus 25. And then I squared we replace with negative 1. So this whole expression becomes 4 plus 25, which is 29. Right? So anytime we're multiplying by two conjugates, this very interesting property takes place where all the i's disappear and we're left with an actual real number. Okay, so now that we're a little bit more comfortable with I, we can go back and revisit some quadratic techniques and look at how that addresses or shows up in solving a quadratic. So we'll start off with something real simple like x squared equals 4. Because we've got it in the form of something squared equals a number, then this would be the square root method. So I want to come in and square root both sides. So x equals plus or minus the square root of 4, which is plus or minus 2. Okay, now on the other one, this is where I is going to show up. So as I'm solving for x squared, I notice that I can get the 16 on the other side. So positive 16 is going to become negative 16. And now I can apply the square root method. So I get x equals plus or minus the square root of negative 16, which is 4i. Okay, then we got down below here. These are two quadratic equations that initially, we'd like to see if we could factor, and we could try that for a few minutes, but if you really think about it, you've got 8, so two things that multiply to give you 8. That's going to end up giving you a 4. Let's see, 8 and that's 4 and 2, and there's no way that 4 plus 2 or 4 minus 2. There's no way to get a 4 out of that, so this actually is not factorable. But we can apply the quadratic formula. So x would be 1, b is negative 4, and c is 8. And then I can fill in the numbers for the quadratic. That's 4ac, okay, all over 2a. And then we can simplify that. Let's see, a negative and a negative is 4. Plus or minus, this would be 16 minus 32 all over 2. And sorry, I'm trying to switch colors here. So 4 plus or minus square root of negative 16 over 2, which would be 4 plus or minus square root of negative 16 is 4i. And I can divide both of those terms by 2, so that would be 2 plus or minus 2i. Okay, so that works out nice. Same thing with this other example, just a little more complicated because the numbers are bigger. But I can, let's see, we could try factoring, but I'll tell you right now it's not going to work. But you're more than welcome to try it if you want. So I'm going to set up all my numbers. All right, so x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so a negative and a negative give me positive 4 plus or minus 16 minus 32 again, so we've seen this, which is 4 plus or minus negative 16 over 16. So that's 4 plus or minus 4i. And at that point, the only thing we can do is we can reduce the fractions, or we can divide 16 out of both. So 4 goes into 16 4 times, so we get 1/4 plus or minus 1/4 I. And that's a perfectly fine answer.